Good evening and welcome to Dreamy Academy. Tonight we embark on a journey not through distant galaxies or the deep past, but into the remarkable universe that resides within each of us, the intricate mechanics of human movement. As we begin, I'd love to know where you're watching from, your city, your country, perhaps even what the night sky looks like outside your window. If you enjoy these peaceful explorations of science, please take a moment to like the video and subscribe. It truly helps this little corner of quiet curiosity grow. To those already subscribed, thank you sincerely for being part of this slow and thoughtful adventure. There's a quiet marvel happening right now, within the very vessel that holds your consciousness as you listen. Every beat of your heart, every gentle shift of your weight, every tiny adjustment of your head as you settle deeper into your pillow, each is a symphony of forces, a dance of levers and pulleys, orchestrated by a wisdom older than memory, refined over eons. It's the constant, silent work of biomechanics. We often take our movements for granted, gliding through the world with an effortless grace that belies the astonishing complexity beneath the surface. Yet, beneath the skin, a universe of precise engineering is unfolding. Bones articulate like ancient gears, muscles contract with the power of microscopic engines, tendons stretch and recoil like finely tuned springs, and all are governed by the elegant, unyielding laws of physics. To contemplate human movement is to open a secret door into the deep history of life on Earth. It is to see how the very forces that shape mountains and guide planets have been harnessed, refined, and miniaturized within the living architecture of our bodies. This subject, quote one Dean, is not merely a collection of facts, it is a profound testament to the ingenuity of evolution, a lyrical expression of how matter can arrange itself to achieve astonishing feats of balance, strength, and fluidity. It rewards patient contemplation because it reveals that the ordinary act of simply being in motion is an extraordinary miracle, a continuous conversation between our internal design and the external world. It is a wonder that, when truly appreciated, can lull the mind into a state of peaceful, informed awe. Have you ever paused to consider the quiet miracle of standing upright? It seems so simple, so fundamental, yet it is an act of exquisite biomechanical balance, a continuous negotiation with gravity. We are, after all, creatures who have chosen to defy the four-legged stability of our ancestors, rising onto two columns of bone to navigate a world of shifting surfaces and subtle inclines. This seemingly effortless defiance is where our journey into human movement science begins. Let's begin by considering the very framework that allows us to stand, our skeleton. Imagine your bones not as static, inert pillars, but as an intricate, living scaffolding, constantly remodeling itself, adapting to the stresses and strains of your daily life. Each bone is a marvel of material science, a composite structure of collagen, which provides flexibility, and calcium phosphate, which lends stiffness and strength. This combination makes bone both remarkably strong, able to withstand significant compression, and surprisingly resilient against fracture. It's a design principle that engineers still strive to emulate, a perfect blend of rigidity and elasticity. But a skeleton alone, no matter how strong, cannot move. It is merely the potential for motion. The magic truly begins where bones meet, at the joints. Picture these intersections not as rigid connections, but as precisely engineered articulations, each designed for a specific purpose, allowing for an astonishing range of movement. Consider the hip, a ball and socket joint, a sphere of bone, the head of the femur, nestled perfectly within a cup-like depression, the acetabulum of the pelvis. This elegant design grants us the ability to swing our leg forward and backward, out to the side, rotate it, and even combine these movements into complex fluid motions like dancing or kicking. Compare this to the knee, a hinge joint, primarily designed for flexion and extension, bending and straightening. While it allows for some rotation when flexed, its primary role is to provide powerful, stable movement in one plane, crucial for walking and running. Each joint, from the intricate carpal bones of your wrist to the robust ankle, speaks a language of its own, defined by its shape and the forces it is designed to manage. These joints are not simply bone on bone. That would lead to friction and rapid wear. Instead, the ends of the bones are covered with articular cartilage, a smooth, slick, resilient tissue that reduces friction to an astonishing degree, far better than any synthetic bearing. And within the joint capsule synovial fluid, a viscous lubricating substance bathes the surfaces, providing nutrients and further reducing friction. The coefficient of friction in a healthy human joint is lower than that of ice on ice, allowing for decades of nearly frictionless movement, a testament to nature's unparalleled engineering. Now, how does this framework actually move? This is where the principle of levers comes into play, a fundamental concept in biomechanics. A lever is a simple machine consisting of a rigid bar that pivots around a fixed point, called a fulcrum. In the human body, your bones act as the rigid bars, your joints are the fulcrums, and your muscles provide the force. This elegant system allows us to amplify force, increase speed, or change the direction of movement. Consider your forearm. When you lift a cup of tea, your elbow acts as the fulcrum. The bicep muscle, attached to your forearm bone, the radius, pulls upwards, providing the effort. The weight of the cup, along with the weight of your forearm itself, represents the load. This is a classic example of a third-class lever, where the effort is applied between the fulcrum and the load. Third-class levers are common in the human body because, while they require a greater force from the muscle, they allow for a large range of motion and speed at the distal end of the limb. A small contraction of your bicep muscle results in a much larger, faster movement of your hand. It's a trade-off. Less mechanical advantage in terms of force, but a significant advantage in terms of speed and reach, which is incredibly useful for manipulating objects and navigating our environment. But the body also employs other types of levers. When you stand on your tiptoes, your ankle acts as a second-class lever. Your toes are the fulcrum. The weight of your body passes through your ankle, the load, and your calf muscles pulling on your heel bone provide the effort. Here, the load is between the fulcrum and the effort, giving you a mechanical advantage, meaning you can lift a heavier load, your entire body weight, with relatively less muscular force. And a first-class lever, where the fulcrum is between the effort and the load, can be seen in the action of nodding your head. Your neck muscles provide the effort, the weight of your head is the load, and the joint between your skull and your spine acts as the fulcrum. This allows for both balance and fine control of head movement. The beauty of this system lies in its dynamic interplay. As you reach for that cup, hundreds of muscles are contracting and relaxing in precise coordination, pulling on bones around joints, creating a seamless, fluid motion. Forces are transmitted, absorbed, and redirected throughout your body. A continuous conversation between structure and function. This understanding allows us to appreciate not just that we move, but how we move, revealing the profound elegance and efficiency embedded within our biological design. There's a particular comfort in understanding that the physical laws governing the universe, the principles of levers, forces, and structural integrity, are not just abstract concepts, but are woven into the very fabric of our being. Every time you stand, walk, or simply shift your posture, you're engaging with these ancient truths, demonstrating a sophisticated mechanical system that has been honed over millions of years of evolution. This knowledge doesn't diminish the wonder of movement, it deepens it, transforming the mundane into the miraculous. It reveals the profound intelligence that exists within the quiet machinery of life, allowing us to perform countless actions without conscious thought, freeing our minds to contemplate the stars or simply to drift into slumber. So we've seen how the skeletal framework and its ingenious joints act as the foundational architecture, and how the fundamental principles of levers allow for the conversion of muscular effort into movement. But this raises a quieter question. What truly powers these levers? How does the living tissue of muscle generate the force necessary for such a diverse array of movements, from the delicate flutter of an eyelid to the powerful leap of a dancer? How do these biological engines translate electrical signals into mechanical action? That question leads us into the microscopic world of muscle fibers and the intricate dance of proteins that lies at the heart of every contraction. Welcome back, dear friends, to Dreamy Academy. We've journeyed through the elegant scaffolding of our bones, marveled at the precision engineering of our joints, and understood the fundamental principles of leverage that govern our movements. We've seen how the body, with its innate wisdom, leverages these physical laws to achieve both robust strength and delicate grace. But as we concluded our last session, a pivotal question remained. What truly powers these levers? What is the living tissue that generates the force, translating electrical signals into mechanical action at a microscopic level? Today, we embark upon a deeper exploration, venturing into the very engines of our being, our muscles. Imagine, if you will, the intricate network of wires, motors, and pulleys that bring a complex machine to life. Within each of us, there's a far more astonishing, self-repairing, and infinitely adaptable system at play. Our muscles are not merely bundles of tissue, they are living power plants, capable of astounding feats of strength, endurance, and precision. They are the silent, tireless workers that sculpt our every gesture, from the grandest leap to the subtlest blink. Have you ever paused to consider the sheer marvel of simply reaching for a glass of water? It seems so effortless, so automatic. Yet, beneath the surface, a symphony of coordinated contractions and relaxations is orchestrating this seemingly simple act. This orchestration begins with our skeletal muscles, the voluntary movers that are firmly anchored to our bones, acting as the dynamic counterpoints to our static skeleton. These are the muscles we consciously command, the ones that allow us to run, to write, to express ourselves through movement, If we were to zoom in, to peel back the layers of this biological machinery, we would first encounter the muscle itself, encased in a shimmering sheath of connective tissue known as fascia. This fascia isn't just a wrapper, it's a structural marvel, organizing the muscle into distinct compartments, allowing individual muscles to slide past each other smoothly, reducing friction and transmitting force. From this main muscle belly, glistening cord-like structures emerge, the tendons. These are the strong, resilient cables of collagen that bridge the gap between muscle and bone, transmitting the contractile force generated by the muscle to the skeletal levers we discussed last time. They are the essential conduits, ensuring that every muscular tug translates into purposeful skeletal motion. But the true magic, the very heart of muscle function, lies within. Each muscle is composed of numerous bundles of muscle fibers, much like a thick electrical cable is made up of many smaller wires. And within each of these individual muscle fibers, we find an even more astonishing level of organization, the myofibrils. These are the true contractile units, running the entire length of the muscle fiber, packed tightly together like miniature engines in a factory. Now, let us truly dive into the microscopic realm, for it is here, within the myofibril, that the secret of muscle contraction is unveiled. Each myofibril is, in essence, a chain of repeating functional units called sarcomeres. Imagine these sarcomeres as tiny, incredibly precise segments, laid end to end, forming a long, continuous contractile ribbon. If you were to look at a sarcomere under a powerful microscope, you would see a beautifully organized pattern of alternating light and dark bands. These bands are formed by two primary types of protein filaments, the thicker myosin filaments and the thinner actin filaments. These filaments are the true stars of our show. The myosin filaments are like tiny armed warriors, each adorned with numerous heads that protrude outwards. The actin filaments, on the other hand, are like finely woven threads, ready to be grasped. The boundaries of each sarcomere are defined by structures called Z-discs, which act as anchors for the actin filaments. In the center of the sarcomere, we find the M-line, which stabilizes the myosin filaments. It is the intricate overlapping arrangement of these actin and myosin filaments that gives skeletal muscle its characteristic striped or striated appearance. And now, for the grand reveal, the sliding filament theory. This elegant theory explains how these microscopic engines generate force. It's not that the individual actin and myosin filaments themselves shorten. Rather, they slide past one another, much like two sets of interlocking fingers drawing closer together. When a muscle contracts, the myosin heads, those tiny warriors, reach out and bind to specific sites on the actin filaments, forming what we call, quote, think of it like this. The myosin heads are like miniature grappling hooks, extending from the thicker myosin rope to latch onto the thinner actin rope. Once attached, these myosin heads pivot, performing a, quote, 5, that pulls the actin filaments inward towards the center of the sarcomere. This action shortens the sarcomere, and since all the sarcomeres in a myofibril and all the myofibrils in a muscle fiber are shortening simultaneously, the entire muscle contracts. But how do these grappling hooks release their grip and prepare for the next pull? This is where adenosine triphosphate, or ATP, our body's primary energy currency, steps onto the stage. ATP binds to the myosin head, causing it to detach from the actin. The ATP is then hydrolyzed, meaning it's broken down, releasing energy that, quote, 6. The myosin head, preparing it to bind to the next available site on the actin filament, further along the filament. This is a cyclical process, a continuous dance of attachment, pivot, detachment, and recocking, repeating thousands upon thousands of times in a single muscle contraction, drawing the actin and myosin filaments ever closer, shortening the muscle with each tiny, powerful stroke. It's a microscopic ballet of immense power and precision. Now, for any machine to work, it needs a control system, a way to initiate and regulate its actions. In the human body, this control system is our nervous system. The command to contract a muscle originates in the brain, travels down the spinal cord, and is carried by specialized nerve cells called motor neurons. Each motor neuron extends a long, slender projection called an axon, which branches out to innervate multiple muscle fibers. The point where a motor neuron's axon terminal meets a muscle fiber is called the neuromuscular junction, a truly fascinating chemical synapse, a secret doorway where electrical signals are translated into chemical messengers. When an electrical signal, an action potential, arrives at the axon terminal, it triggers the release of a chemical neurotransmitter called acetylcholine into the synaptic cleft, the tiny space between the nerve and muscle. This acetylcholine then binds to specialized receptors on the muscle fiber's membrane, the sarcolemma. This binding acts like a key in a lock, opening ion channels and generating an electrical signal, another action potential that rapidly sweeps across the entire muscle fiber. This electrical signal is the crucial trigger. It travels deep into the muscle fiber through a network of tiny invaginations of the sarcolemma called T-tubules, reaching the sarcoplasmic reticulum. The sarcoplasmic reticulum is a specialized endoplasmic reticulum within muscle cells, acting as an internal reservoir for calcium ions. Upon receiving the electrical signal, the sarcoplasmic reticulum releases a flood of calcium ions into the sarcoplasm, the cytoplasm of the muscle cell. And here, another layer of exquisite control is revealed. On the actin filaments, there are two regulatory proteins, troponin and tropomyosin. In a relaxed muscle, tropomyosin acts like a physical barrier, blocking the binding sites on the actin filaments where the myosin heads would normally attach. But when calcium ions are released, they bind to troponin. This binding causes troponin to change shape, which in turn pulls tropomyosin away from the actin binding sites, effectively lifting the barrier. It's like unlocking a secret door, allowing the myosin heads to finally bind to the actin and initiate the sliding filament mechanism. Without calcium, the muscle remains relaxed. With calcium, the contraction begins. This entire process, from the initial thought to the final contraction, is astonishingly rapid and coordinated. It's an elegant cascade of electrical and chemical events, culminating in the mechanical force that allows us to interact with our world. The precision with which our muscles generate force is equally remarkable. It's not an all-or-nothing proposition. We can lift a feather with delicate ease or hoist a heavy weight with maximal effort, all thanks to a principle known as motor unit recruitment. A motor unit consists of a single motor neuron and all the muscle fibers it innervates. Some motor neurons might control just a few muscle fibers, allowing for fine, precise movements. like those in our eyes or fingers, while others might control hundreds or even thousands of fibers, generating powerful, gross movements like those in our legs. When we need to generate more force, our nervous system simply recruits more motor units. It starts with the smaller, weaker units, and as more force is required, it progressively activates larger, stronger units. This allows for a smooth, graded increase in muscle tension. Furthermore, the frequency of stimulation also plays a crucial role. If a muscle fiber is stimulated rapidly, before it has a chance to fully relax, the successive contractions add up, a phenomenon known as wave summation, leading to a stronger, sustained contraction called tetanus. This sophisticated interplay of recruitment and frequency allows for the incredible adaptability and strength of our muscular system. Whether we are performing a concentric contraction, where the muscle shortens as it generates force, like lifting a bicep curl, an eccentric contraction, where the muscle lengthens under tension, like slowly lowering a weight, or an isometric contraction, where the muscle generates force without changing length, like holding a plank. The underlying microscopic dance of actin and myosin, powered by ATP and regulated by calcium, remains the same. It is a testament to nature's genius, a system of unparalleled efficiency, resilience, and adaptability. As we conclude this exploration of muscle mechanics, I invite you once more to hold this sense of wonder, to truly appreciate the universe within each of us. The next time you reach for something or take a step or even just smile, remember the silent, tireless work happening beneath your skin. Remember the elegant design of the sarcomeres, the intricate dance of actin and myosin, the precise command of the nervous system, and the vital role of calcium and ATP. These are not just abstract scientific concepts. They are the very essence of what makes us move, what makes us live, what allows us to experience the world in all its dynamic glory. In our next session, we will delve into the fascinating world of energy systems, uncovering how our bodies fuel these incredible muscular engines, ensuring they have the ATP needed for their continuous miraculous work. Until then, keep observing, keep questioning, and keep marveling at the biomechanical masterpiece that is you. And so, we arrive at the very heart of the matter, don't we? We've journeyed through the intricate dance of bones and joints, observed the elegant mechanics of levers, and peered into the microscopic marvel of muscle contraction, witnessing the myosin heads tirelessly pulling actin filaments inward. We've seen the spark of a neural command ignite a cascade of chemical events, culminating in that beautiful, purposeful shortening. But a crucial question lingers, a fundamental query that underpins every single movement, from the most delicate whisper of a fingertip to the explosive power of a leap. Where does the energy for this incessant demanding work come from? For every cross bridge that forms, every power stroke that pivots, every calcium ion that is meticulously pumped back into its storage, there is a silent, constant demand for fuel. This fuel, this universal currency of cellular life, is adenosine triphosphate, or think of ATP not merely as energy, but as the very pulse of existence within our cells, the immediate ready-to-use power source that makes everything happen. Without it, the intricate machinery of muscle contraction grinds to an immediate halt. It is the invisible orchestrator, the silent engine oil in the microscopic gears of life. Today, we embark on a fascinating exploration into the body's extraordinary energy systems, the brilliant, adaptable mechanisms that tirelessly replenish our ATP supply, allowing us to move, to think, to live. Prepare yourselves for a journey into the exquisite wisdom of biological engineering, where efficiency and adaptability reign supreme. We will discover how our bodies, with astonishing foresight, have developed 3 primary pathways to synthesize ATP, each meticulously designed to meet the varying demands of our movements, from a fleeting flicker of an eyelid to an arduous endurance challenge. Let us begin with the system built for speed, for that instantaneous explosive burst of power, the phosphagen system, sometimes called the ATP peaker system. Imagine you need to react instantly, to sprint away from danger, to lift an impossibly heavy object for just a second, or to initiate any powerful movement. There's no time for complex chemical reactions. You need energy now. This system is our body's immediate high-octane rocket booster, ready to fire at a moment's notice. Deep within your muscle cells, you have a small, precious reserve of ATP, enough for maybe 2-3 seconds of maximal effort. But critically, you also store another high-energy compound, creatine phosphate, PCR. Think of PCR as a super-fast battery charger for ATP. When that initial ATP reserve dwindles, an enzyme called creatine kinase swiftly transfers a phosphate group from PCR directly to a depleted ADP, adenosine diphosphate molecule, instantly regenerating ATP. It's a beautifully simple, one-step reaction, a direct transfer that bypasses longer, more complex metabolic pathways. This system is a marvel of immediacy. It's why you can execute a powerful jump, a single heavy lift, or the first few rapid strides of a sprint. It's the flash of lightning, the sudden surge. But like any rocket booster, its fuel is limited. The stores of PCR are small, capable of sustaining maximal effort for only about 8 to 10 seconds, perhaps up to 15 seconds if you're exceptionally well trained. Once depleted, the system needs time to recover, to rebuild those PCR stores during periods of rest. It's a testament to the body's wisdom. Maximum power, minimum delay for those critical fleeting moments. As the phosphagen system begins to wane, unable to sustain the demand for ATP, our bodies seamlessly transition to the next gear, engaging a more robust though slightly slower energy pathway, the glycolytic system, or anaerobic glycolysis. This system steps in when you need to maintain a high level of intensity for a longer duration than the phosphagen system can provide. Think of a 400-meter sprint, a sustained burst of intense activity for 30 seconds to a few minutes. Here, our primary fuel source shifts to glucose, a simple sugar obtained from the breakdown of carbohydrates we consume, or from glycogen, the stored form of glucose found in our muscles and liver. Glycolysis is essentially the process of breaking down a glucose molecule into 2 molecules of pyruvate. This multi-step process, while more involved than the phosphagen system, is still relatively rapid and, crucially, does not require oxygen. This is why we call it, quote, 7. For every molecule of glucose processed through glycolysis, we net a modest yield of 2, or sometimes 3, molecules of ATP. While significantly less efficient than systems that use oxygen, it's a vital bridge, providing a rapid supply of energy when oxygen delivery to the working muscles can't keep pace with demand. Now, here's where things get interesting and often misunderstood. Because oxygen isn't present in sufficient quantities to process the pyruvate further, the pyruvate is converted into lactate. And alongside lactate, hydrogen ions are also produced. It's the accumulation of these hydrogen ions, not the lactate itself, that causes the muscle acidity and the familiar burning sensation we associate with intense prolonged exercise. This drop in pH inhibits the function of key enzymes involved in muscle contraction and ATP production, leading to the sensation of fatigue and forcing us to slow down. Lactate, in fact, can even be shuttled to other tissues and used as a fuel source when oxygen is available. It's a sophisticated process where the body, even under duress, tries to find utility in its byproducts. The glycolytic system is like a powerful, short-lived surge, capable of fueling intense efforts for approximately 30 seconds to about 2-3 minutes. It's your body's solution for that middle ground of exertion, not an immediate explosion, but a sustained, powerful effort before the endurance engine fully kicks in. It's a testament to the body's capacity to adapt and continue performing, even when oxygen is scarce. Finally, we arrive at the grand master of energy production, the system that powers our daily lives, our long endurance feats, and indeed, our very resting metabolism, the oxidative system, also known as aerobic respiration. This system is the slow, steady, and incredibly efficient engine that requires a constant supply of oxygen. Unlike its anaerobic counterparts, the oxidative system is a deep well of energy, capable of producing a vast amount of ATP. It's the marathon runner, not the sprinter. It's the quiet, tireless engine that allows us to walk for hours, to maintain posture, to digest food, and to recover from intense exercise. It's the system that truly unlocks the full energetic potential of our fuel sources. The oxidative system has multiple pathways, all converging on the production of a staggering amount of ATP. Its primary fuel sources are not just carbohydrates, glucose glycogen, but also fats, fatty acids, and to a lesser extent, proteins, amino acids. This remarkable versatility means our body has an almost inexhaustible supply of fuel for this system, especially from our fat stores. When oxygen is present, the pyruvate produced from glycolysis doesn't convert to lactate. Instead, it enters the mitochondria, often called the "what." Here, it undergoes further breakdown in a cyclical series of reactions known as the Krebs cycle, or citric acid cycle. This cycle generates a small amount of ATP directly, but more importantly, it produces a wealth of high-energy electron carriers, NADH and FADH2. These electron carriers then feed into the final, most productive stage, the electron transport chain, ETC. Imagine a sophisticated assembly line within the mitochondria, where electrons are passed down a series of protein complexes. As they move, energy is released, which is used to pump hydrogen ions across a membrane, creating a gradient. This gradient is then harnessed, much like water flowing through a turbine, to power the enzyme ATP synthase, which generates the bulk of our ATP. And what is the final electron acceptor at the end of this chain? The molecule that keeps the entire process flowing. Oxygen. Without oxygen, the chain grinds to a halt and vast ATP production ceases. The efficiency is astounding. For every molecule of glucose, the oxidative system can yield approximately 32 molecules of ATP, a dramatic increase compared to the mere 2-3 from glycolysis alone. When fats are used as fuel, the ATP yield is even higher, making them an incredibly dense energy source for prolonged lower-intensity activities. You see, these three systems do not operate in isolation, like distinct separate switches. Instead, they function on a magnificent continuum, always working together, with one system dominating based on the intensity and duration of the demand. Consider the simple act of standing up from a chair. The initial burst uses the phosphagen system. As you maintain your posture, the oxidative system quietly takes over. Now imagine you suddenly decide to sprint across the room. The phosphagen system fires instantly for those first few powerful strides. As you continue, the glycolytic system ramps up, providing a rapid, though less efficient, supply of ATP. If you were to continue running, perhaps on a treadmill for a long distance, your body would transition predominantly to the oxidative system, drawing primarily on carbohydrates and fats, efficiently producing ATP for sustained effort. Even as you run a marathon, the glycolytic system might still contribute during bursts of speed or uphill climbs, but the oxidative system remains the tireless workhorse. This elegant interplay, this seamless transition between energy pathways, is a testament to the body's profound intelligence and adaptability. It ensures that you always have the right type of fuel, delivered at the right speed, to meet the precise demands of your movement, from the microscopic engines of our sarcomeres to the vast networks of our energy systems. Every aspect is a masterclass in biological engineering, a silent symphony of forces and fuels. We have now unveiled the secret behind the tireless work of our muscles, the constant replenishment of the energy currency that powers every contraction. We've seen the wisdom in having systems for immediate power, for sustained bursts, and for enduring efficient work. But how does this magnificent machinery receive its marching orders? How do all these intricate systems, from neural command to energy supply, integrate into purposeful, coordinated movement? In our next exploration, we will delve deeper into the fascinating world of neural control, discovering how the brain orchestrates this symphony, transforming intention into action and turning the complex into the beautifully simple act of human movement. Until then, continue to move with a newfound appreciation for the silent, astonishing work happening within you. Welcome back, dear friends, to Dreamy Academy. We've journeyed through the living architecture of the skeleton, marveled at the mechanical ingenuity of our joints, and uncovered the powerful engines of our muscles, fueled by an intricate dance of energy systems. We've explored the scaffolding, the machinery, and the very fuel that ignites movement. But as we stand at this precipice of understanding, a profound question naturally arises, echoing in the quiet chambers of our collective curiosity. How does this magnificent symphony of bones, tendons, and fibers know what to do? Who is the conductor of this biological orchestra? Today we embark upon the final, most astounding frontier of our biomechanical exploration. The central nervous system, the master orchestrator, the silent commander, the very seat of our will and our ability to interact with the world. Imagine, if you will, a universe within each of us, a complex network of pathways, signals and computations far more intricate than any supercomputer ever conceived. This is the realm of neural control, where thought transforms into action, where intention blossoms into graceful, purposeful movement. Have you ever paused to consider the sheer complexity involved in simply reaching for a cup of tea or taking a single step? It's not merely a muscle contracting, it's a cascade of electrical impulses, a finely tuned dialogue between billions of cells, a real-time negotiation between desire and execution. We are, each of us, walking miracles of neural engineering. At the heart of this command structure lies the central nervous system, CNS, comprising the brain and the spinal cord. It is the grand central station, the processing hub, the decision maker. Extending from it, like countless delicate branches, is the peripheral nervous system, PNS, which acts as the body's vast communication network, carrying messages to and from every limb, every organ, every muscle fiber. Think of the CNS as the government and its main offices, and the PNS as the postal service and telephone lines, connecting every citizen to the central authority. Without this seamless, instantaneous communication, our bodies would be inert statues, magnificent in form but utterly devoid of motion and life. Let us first turn our gaze to the brain, the unparalleled architect of our movements. Within its convoluted folds resides the subtary motor cortex, a region specifically dedicated to the planning, control, and execution of voluntary movements. It's here, in the primary motor cortex, the premotor cortex, and the supplementary motor area, that the initial spark of intention ignites. When you decide to lift your arm, that decision isn't just a fleeting thought. It's a cascade of neural activity originating in these very regions. The motor cortex doesn't just send a simple quote 9 command. It orchestrates the intricate sequence of muscle activations, the precise timing, the necessary force, and the direction of movement. It's the composer, drafting the score for the symphony of your body. But movement is rarely a simple linear process. It requires refinement, smoothness, and the ability to adapt. For this, the motor cortex relies heavily on crucial collaborators within the brain. Consider the basal ganglia, a collection of interconnected nuclei nestled deep within the cerebrum. These structures act as the brain's quality control department, playing a vital role in initiating and stopping movements, regulating their intensity, and suppressing unwanted involuntary motions. They ensure that our actions are smooth, deliberate, and appropriate to the task at hand, filtering out extraneous noise from the motor command. Without the basal ganglia, our movements might become hesitant, jerky, or even uncontrollable, as seen in certain neurological conditions. They are the editors, refining the raw draft of movement into a polished, coherent narrative. Then there is the cerebellum, that beautiful cauliflower-shaped structure nestled at the back of the brain, often called the quote 10. Its role in motor control is anything but small. The cerebellum is the master coordinator, the exquisite choreographer of our movements. It receives vast amounts of sensory information about our body's position, balance, and ongoing movements, then compares this feedback to the intended motor plan from the motor cortex. If there's a discrepancy, if your hand is veering slightly off target, or your balance is faltering, the cerebellum instantly calculates the necessary adjustments and sends corrective signals. It's also instrumental in motor learning, helping us to perfect skills through practice, transforming clumsy attempts into fluid, automatic actions. It is the metronome, ensuring rhythm and precision, and the diligent teacher, guiding us towards mastery. From these cerebral command centers, the intricate instructions for movement must travel down the spinal cord, the body's superhighway of information. Encased within the protective column of your vertebrae, the spinal cord serves as both a conduit and a processing hub. Descending tracts of nerve fibers carry the motor commands from the brain to the muscles, while ascending tracts relay sensory information from the body back to the brain, creating a continuous two-way dialogue. At the very end of this descending pathway are the motor neurons, often called the final common pathway. These specialized nerve cells, whose cell bodies reside in the spinal cord, extend their long axons directly to individual muscle fibers. We touched upon their role in Chapter 2, recalling how they form the neuromuscular junction, the precise chemical synapse where the electrical signal from the nerve is converted into a chemical message, acetylcholine, triggering muscle contraction. This final critical step ensures that the brain's elaborate plan is translated into physical force, causing the sarcomeres to slide and the muscle to shorten. But movement is not a one-way street. It's a dynamic, responsive process. Our bodies are equipped with an astonishing array of sensory receptors that constantly feed information back to the CNS, allowing for real-time adjustments and refinements. This feedback loop is essential for coordinated, efficient, and safe movement. Imagine trying to walk in the dark without any sense of where your feet are or what the ground feels like. This is why sensory input is so vital. Perhaps the most fascinating of these are the proprioceptors, our body's internal GPS system. These specialized receptors provide us with a subconscious awareness of our body's position and movement in space, even without looking. Muscle spindles. Embedded within the belly of our muscles, these delicate structures are exquisitely sensitive to changes in muscle length and the rate at which that length changes. When a muscle is stretched, the spindles send signals back to the spinal cord, triggering a reflex contraction in the stretched muscle to prevent overstretching. This is the basis of the familiar quote 12. Think of the doctor tapping your knee with a hammer, causing your leg to kick. This reflex helps maintain posture and protects muscles from injury. They are the vigilant sentinels, always reporting on the state of muscle elongation. Golgi tendon organs, GTOs. Located in the tendons where muscle fibers attach to bone, GTOs are sensitive to changes in muscle, tension, or force. When a muscle generates excessive force, the GTOs send inhibitory signals to the spinal cord, causing the muscle to relax. This protective mechanism prevents muscles and tendons from being damaged by overwhelming loads. They are the wise guardians, preventing self-harm from excessive effort. Beyond these, joint receptors. In our joint capsules and ligaments provide information about joint position, movement, and stress, contributing to our overall sense of kinesthesia, the awareness of movement, and of course, cutaneous receptors. In our skin provide crucial information about touch, pressure, and texture, influencing our grip, balance, and interaction with objects. All this sensory information, the stretch of a muscle, the tension in a tendon, the angle of a joint, the feel of the ground beneath our feet, rushes back up the spinal cord to the brain, forming a continuous stream of data. The cerebellum, it in particular, uses this feedback to fine-tune ongoing movements, making subtle corrections that allow us to maintain balance, hit a target, or execute complex athletic maneuvers with precision. It's like a sophisticated autopilot system, constantly monitoring and adjusting the flight path. The beauty of this neural control system is its remarkable capacity for motor learning and adaptation. From the wobbly first steps of a toddler to the elegant pirouette of a dancer, our nervous system is constantly learning, refining, and optimizing motor programs. Repetition strengthens neural pathways, making movements more efficient and automatic. The brain exhibits astonishing plasticity, literally rewiring itself in response to experience, laying down new connections and pruning away less efficient ones. This is why practice makes perfect. Each repetition is a lesson for your brain, a chance to refine the choreography and improve the execution. The cerebellum, again, plays a central role here, encoding new motor memories and helping us to develop skilled movements that eventually become unconscious habits. Ultimately, all these components, the intentional spark in the motor cortex, the refinement by the basal ganglia and cerebellum, the rapid transit via the spinal cord, the precise activation at the neuromuscular junction, and the continuous stream of sensory feedback converge to create coordinated and synergistic movement. Our bodies rarely move in isolation. Every action is a complex interplay of muscles working together. Some muscles, agonists, contract to produce the movement, while others, antagonists, relax or lengthen to allow it. Still others, synergists, assist the prime movers, and stabilizers hold parts of the body steady. The nervous system masterfully orchestrates this grand ensemble, activating and inhibiting muscles with exquisite timing and force, transforming simple intentions into the breathtaking complexity of human motion. So, the next time you simply stand, walk, or reach for something, take a moment to marvel at the silent, tireless work happening within. You're witnessing the culmination of billions of years of evolution, a biological machine of unparalleled sophistication, guided by a network of nerves that represents one of nature's most profound achievements. The human body truly is a universe of its own, constantly communicating, adapting, and moving with a grace and precision that continues to inspire awe. We conclude this chapter with a renewed sense of wonder for the unseen forces that shape our every action, for the electrical whispers that breathe life into our forms. The dance of biomechanics is not merely a mechanical one, it is a neurological ballet, a testament to the elegant wisdom embedded within our very being. In our next exploration, we will weave these threads together, examining how these integrated systems contribute to the extraordinary feats of human performance and the subtle nuances of everyday movement. Until then, carry this newfound appreciation with you, and observe the marvel of movement in every step, every gesture, every breath. And so, we arrive at a pivotal moment in our shared journey, don't we? Having meticulously charted the individual landscapes of the human body, the silent architecture of our bones and joints, the microscopic engines of our muscles, the intricate power grid of our energy systems, and the grand conductor that is our central nervous system. We now stand at the threshold of understanding their magnificent synthesis. We have explored the instruments, learned their individual melodies, and now, friends, we are ready to hear the full symphony. Have you ever paused to consider the sheer, breathtaking orchestration behind a simple act, like reaching for a cup of tea? Or the almost miraculous coordination required to navigate a crowded street, avoiding obstacles with unconscious grace? These aren't isolated events, but the culmination of every principle we've discussed, woven together into a living, breathing tapestry of biomechanical brilliance. This chapter is where we connect the threads, where we witness the systems we've so carefully dissected reassemble into a dynamic, integrated whole. We're moving from the granular to the grand, from the individual components to the complete, astonishing mechanism of human movement. Imagine, if you will, a master clockmaker whose every gear, spring, and lever we've admired in isolation. Now we watch as these pieces are assembled, each perfectly calibrated to interact with the next, culminating in a timepiece that not only tells the hour, but keeps the rhythm of life itself. This is the human body in motion, a precision instrument, constantly adjusting, adapting, and performing, often without our conscious command. Let us begin with the movements we take for granted, the silent miracles of our everyday existence. Take walking, for instance. It seems so simple, doesn't it? A rhythmic progression, one foot after the other. Yet beneath this apparent simplicity lies an extraordinary interplay of forces and feedback. As we lift one foot, our central nervous system, that astute conductor, is already anticipating the shift in our center of gravity. Proprioceptors in the standing leg instantly relay information about joint angles and muscle tension, allowing the brain to subtly adjust the musculature for balance. Our hip and knee joints, those elegant hinges and ball and sockets, articulate smoothly, guided by the precise contraction and relaxation of agonist and antagonist muscle groups. The quadriceps extend the leg forward, the hamstrings flex it back, while the gluteals provide the powerful propulsion. And what fuels this continuous dance? Our energy systems are working in perfect concert. For the sustained, low-intensity effort of walking, the oxidative system reigns supreme, efficiently generating ATP from oxygen and available fuel sources, allowing us to cover miles without exhaustion. But when we encounter an unexpected curb, or quicken our pace to cross the street, there's a momentary surge from the phosphagen and glycolytic systems, providing that burst of immediate power. All of this happens seamlessly, orchestrated by neural commands that flow like electricity through our motor neurons, activating motor units in a cascade of carefully timed contractions. The bones act as levers, transmitting these forces, while the joints ensure fluidity and range of motion, cushioned by cartilage, lubricated by synovial fluid. It is a cyclical marvel, a continuous process of falling forward and catching ourselves, repeated thousands of times a day, a testament to the body's innate wisdom. Consider also the quiet resilience of posture. Even as you sit or stand listening to these words, your body is engaged in a ceaseless silent battle against gravity. It's not a static hold, but a dynamic equilibrium, a constant micro-adjustment. Your deep postural muscles, often overlooked, are tirelessly working, contracting isometrically to maintain spinal alignment. The muscle spindles and Golgi tendon organs are continuously sending streams of data back to your brainstem and cerebellum, informing the CNS of the slightest sway or shift. Reflex arcs are firing, making instantaneous corrections, often before you're even aware of them. This continuous feedback loop ensures that your head remains balanced atop your spine, your torso upright, your weight distributed evenly. It is a subtle yet profound demonstration of neuromuscular control, energy expenditure, and skeletal support working in perfect harmony, a testament to the body's commitment to structural integrity. And what of the exquisite precision of fine motor skills? The delicate dance of our fingers as we write, tie a shoelace, or manipulate a complex tool. Here, the CNS truly shines in its ability to recruit precisely the right number of motor units, often smaller ones, to generate minute controlled forces. The sensory feedback from the skin, joints, and muscles in our hands and wrists is incredibly rich, allowing for real-time adjustments that translate intention into incredibly nuanced action. The intricate articulation of the carpals and metacarpals, the powerful yet agile flexors and extensors of the forearm, all contribute to this remarkable dexterity. It's a symphony played on the smallest instruments, where every note is perfectly placed. But the human body, in its boundless capacity, is not content with mere everyday functionality. It yearns for more, capable of ascending to peaks of extraordinary performance that leave us in awe. This is where the integration of our systems truly reveals its spectacular potential. Think of an athlete engaged in a feat of strength and power, a weightlifter hoisting an incredible load, or a sprinter exploding from the blocks. Here, the central nervous system becomes a potent amplifier. It maximizes motor unit recruitment, sending powerful synchronized commands to as many muscle fibers as possible. The phosphagen system springs into immediate action, providing the rapid ATP necessary for that initial explosive burst. The glycolytic system then takes over for the subsequent seconds, fueling the sustained effort. The muscles, now contracting with maximal force, pull on the skeletal levers, generating immense torque around the joints. The bones, designed for resilience, bear the load, while the ligaments and tendons, stretched to their limits, transmit the force efficiently. It is a magnificent display of coordinated energy transfer and muscular might, all orchestrated by a brain honed through countless hours of training to bypass inhibitory signals and unleash latent potential. Now shift your focus to the enduring marvel of cardiovascular endurance, embodied by a marathon runner gliding effortlessly through mile after mile. This is the domain of the oxidative system, operating at its most efficient. The body has adapted to deliver oxygen and nutrients to the working muscles with unparalleled efficacy. The heart, a tireless pump, has grown stronger, pushing more blood with each beat. The lungs have become more adept at gas exchange. Mitochondria, the powerhouses within muscle cells, have proliferated, ready to churn out vast quantities of ATP from fats and carbohydrates. The muscles themselves have developed a higher capillary density and greater oxidative enzyme activity, making them more resistant to fatigue. The CNS, while still coordinating movement, shifts its focus to maintaining rhythm, managing perceived exertion and optimizing pacing, drawing upon learned patterns of movement. The skeletal system provides the stable framework, absorbing impact with each stride, while the joints maintain their fluid motion over hours of repetitive stress. It is a testament to the body's capacity for sustained, efficient work, a journey of physiological adaptation. And then there is the breathtaking fluidity of agility and coordination. The dancer executing a complex sequence of turns and leaps, or the basketball player dribbling through defenders with seemingly impossible grace. This is where the sensory feedback loop from proprioceptors, joint receptors, and visual input becomes almost instantaneous. The cerebellum, a master of timing and coordination, is working overtime, comparing intended movements with actual movements and making micro-adjustments in real time. The motor cortex fires precise commands, activating and inhibiting muscle groups in rapid succession. Muscles contract and relax with exquisite timing, creating a ballet of tension and release. The energy systems provide the necessary bursts of power for quick changes in direction or elevation, while the skeletal levers and joints allow for maximal range of motion and swift transitions. It is a dynamic dialogue between sensation and action, a continuous negotiation with gravity and momentum, resulting in movements that are both powerful and exquisitely controlled. What we witness in these extraordinary feats, and indeed in every mundane movement, is the profound principle of motor learning taken to its pinnacle. With repeated practice, the CNS refines these integrated patterns. Neural pathways become more efficient, muscle recruitment more precise, energy utilization more optimized. Movements that once required conscious effort become automatic, ingrained into our very being, allowing us to perform with greater speed, power, and precision. It is the body's way of saying, I understand, and I will do it better next time. So as we bring this chapter to a close, we are left with a profound sense of wonder, aren't we? We've journeyed from the foundational elements to the integrated marvel. We've seen how bones articulate, muscles contract, energy flows, and the nervous system orchestrates it all. The human body is not a collection of isolated parts, but a living, breathing, exquisitely integrated system, where each component contributes to the harmonious whole. It is a testament to intelligent design, a universe of constant, silent work unfolding within each of us. Understanding this integration is not merely an academic exercise. It is the key to unlocking human potential, to preventing injury, to optimizing training, and to truly appreciating the miracle that is our own physical form. It encourages us to listen to our bodies, to respect their intricate workings, and to marvel at the silent, constant symphony of biomechanics that empowers every step, every breath, every gesture. We are, each of us, a masterpiece of movement science. We've journeyed together, haven't we? From the silent architecture of bone to the microscopic dance of muscle, through the intricate pathways of energy and the grand orchestration of the nervous system, culminating in the integrated ballet of movement and the profound wisdom of motor learning. We've peeled back layers, marveling at the genius embedded within each of us. But here, at this juncture, we arrive at perhaps the most astonishing aspect of all, the body's ceaseless capacity for adaptation and its unwavering resilience. You see, The human body is not a static blueprint, frozen in time from birth. Oh no, it is a living canvas, constantly being repainted, reshaped, and refined by the brushstrokes of our experiences, our challenges, and our very intentions. It is an ongoing conversation between internal design and external demand, a testament to dynamic equilibrium. Have you ever truly paused to consider what an extraordinary feat this is? To be a system that not only performs, but evolves with every step, every lift, every moment of rest. Let us embark on this final, yet eternally unfolding exploration of how this intricate universe within us not only functions but transforms. Imagine, for a moment, the bones we first encountered, those sturdy, elegant levers. We spoke of their mineral strength, their capacity to bear loads, but they are far more than inert scaffolding. They are living tissue, perpetually engaged in a silent, meticulous dialogue with the forces that act upon them. This conversation is eloquently captured by what we know as Wolff's Law. Simply put, Wolff's Law states that bone in a healthy person or animal will adapt to the loads under which it is placed. If loading increases, the bone will remodel itself to become stronger to resist that loading. If loading decreases, the bone will become weaker due to the absence of the stimulus. Think of it. Every time you walk, run, or lift, microscopic stresses are communicated to your bones. Specialized cells, the osteocytes, osteoblasts, and osteoclasts receive these signals. They are the diligent architects and demolition crews of your skeletal system. Osteoblasts lay down new bone matrix, reinforcing areas of high stress, thickening the cortical bone, or increasing trabecular density. Simultaneously, osteoclasts resorb old or less stressed bone. There's a quiet, continuous remodeling happening within you right now, a slow, methodical sculpting in response to your daily life. It's why an astronaut in zero gravity experiences bone density loss, and why an athlete who consistently trains with resistance develops stronger, denser bones. Your bones are literally listening to your life, responding to the whispers and shouts of mechanical stress. They are a testament to the body's profound efficiency, never building more than necessary, yet always ready to reinforce where needed. This is the very essence of structural adaptation. But this adaptive genius isn't confined to the bones. Consider the intricate network of connective tissues, the tendons that tether muscle to bone, the ligaments that embrace and stabilize joints, the fascia that weaves through every muscle fiber and organ, holding us together in a cohesive whole. These tissues too are living, breathing entities, possessing their own remarkable capacity for change. When subjected to consistent, appropriate mechanical stress, tendons and ligaments don't just hold, they strengthen. Their collagen fibers, the very fabric of their being, become more numerous, more organized, and more robust. They increase their tensile strength, becoming better equipped to transmit forces without tearing. This is why a well-trained runner develops more resilient Achilles tendons, or a weightlifter builds stronger patellar tendons. Conversely, prolonged inactivity can lead to a reduction in their strength and elasticity, making them more susceptible to injury. They are like finely tuned cables, constantly adjusting their gauge and tension in response to the demands placed upon them, ensuring the integrity and stability of every movement. And what of our muscles, those microscopic engines we explored in Chapter 2? Their plasticity is perhaps the most visible manifestation of the body's adaptive power. We speak of hypertrophy, the growth and strengthening of muscle fibers in response to resistance training. When you lift weights, climb stairs, or engage in any activity that challenges your muscles, you create microscopic damage, a signal for growth. The body, in its infinite wisdom, doesn't just repair, it over-repairs. It synthesizes new contractile proteins, actin and myosin, increases the number and size of myofibrils, and enhances the sarcoplasmic reticulum's capacity for calcium storage. The result is a larger, stronger, more powerful muscle, better prepared for future demands. Conversely, without sufficient stimulus, muscles experience atrophy. Like a garden untended, they begin to recede, reducing in size and strength. This constant ebb and flow, this growth and regression, is a magnificent demonstration of the body's resourcefulness, its ability to allocate resources precisely where they are needed, maintaining optimal function with minimal energetic cost. Your muscles are the sculptors of your physical form, constantly being moulded by the clay of your efforts. Beyond the visible changes in bone and muscle, a profound transformation occurs within the very command center itself, the nervous system. We touched upon motor learning in the previous chapter, how the CNS refines integrated patterns, but this refinement isn't just about better execution. It involves tangible, structural and functional changes within the brain and spinal cord. This is neurological plasticity. Every time you learn a new skill, practice a complex movement, or even adjust to a new environment, your brain is rewiring itself. Synapses, the tiny junctions where neurons communicate, become stronger, more efficient, or even new ones are formed. Neural pathways become more myelinated, allowing signals to travel faster. The motor cortex, basal ganglia, and cerebellum, which we explored as orchestrators of movement, literally reshape their internal maps, dedicating more neural real estate or refining the precision of existing circuits for frequently performed actions. Think of a musician learning a new piece, or a dancer mastering a complex sequence. Their brains aren't just remembering, they are physically adapting, optimizing the neural architecture for that specific skill. This is the ultimate expression of the body as a learning machine, continuously updating its software and hardware in unison. All these individual adaptations in bone, connective tissue, muscle, and nervous system are not disparate events. They are interwoven, guided by an overarching principle known as the SAID principle. Specific adaptation to imposed demands. This principle elegantly summarizes the body's intelligent response to stress. It states that the body will adapt specifically to the type of stress placed upon it. If you consistently engage in endurance running, your body will adapt by increasing mitochondrial density in your muscle cells, enhancing cardiovascular efficiency, and improving the oxidative capacity of your energy systems. Your bones will strengthen along the lines of force experienced during running. Your ligaments and tendons will become more resilient to repetitive impact. If you consistently lift heavy weights, your body will adapt by increasing muscle fiber size and strength, enhancing neural recruitment patterns, and increasing bone density in load-bearing areas. The SAID principle underscores the precision of the body's adaptive mechanisms. It doesn't just get, quote 14, it gets specifically better at what you ask it to do. It's a profound testament to the body's wisdom, its ability to specialize and optimize for survival and performance. And what happens when this marvelously adaptive system encounters a challenge that pushes it beyond its current capacity, resulting in injury? Here, we witness the astonishing power of resilience and healing. The body, in its inherent design, is also a tireless physician, equipped with an intricate cascade of repair mechanisms. From the initial inflammatory response which clears debris and sets the stage for repair, to the proliferation of new cells and the meticulous remodeling of damaged tissues, the body works silently, persistently, to restore integrity. A fractured bone, given the right conditions, meticulously knits itself back together, often stronger at the site of the break. A torn muscle fibre regenerates. Even tissues with limited regenerative capacity, like cartilage, have sophisticated, albeit slower, repair processes. This capacity for self-repair, this innate drive toward healing, is perhaps the most humbling and inspiring aspect of our biological existence. It speaks to a deep, fundamental wisdom within, a constant striving for wholeness and function. As we conclude this exploration, we stand before an even grander realization. The human body is not merely an assembly of parts, nor even just an integrated system. It is a living, breathing, evolving narrative. It is a story of continuous change, of challenges met and overcome, of wisdom gained through experience. Every scar tells a tale of healing. Every strengthened muscle speaks of effort. Every refined movement whispers of learning. We have moved from dissecting the components to appreciating their seamless integration, and now to understanding their dynamic, ever-changing nature. The journey through biomechanics and human movement science reveals not just how we move, but who we are in motion. Magnificent, adaptable beings, capable of extraordinary feats of strength, endurance, precision, and above all, transformation. So as you step away from our time together in Dreamy Academy, I invite you to carry this profound appreciation with you. Look at your own body, look at the movements around you with new eyes. See the silent, continuous symphony of adaptation playing out. Recognize the living canvas, perpetually being painted and repainted by the very act of living. For within each of us lies not just a mechanism, but a miracle, a testament to life's astonishing capacity to grow, to heal, and to become. And in that, there is boundless wonder and an endless invitation to explore further. Thank you for joining me on this incredible journey. May your own journey of movement and discovery be rich and full of wonder. And so, we arrive at a threshold, dear friends, a quiet moment of pause at the end of a long and illuminating journey through the astonishing architecture of human movement. We've peeled back layers, explored the intricate dance of bone and muscle, traced the fiery pathways of energy, and marveled at the lightning-fast directives of the nervous system. We've witnessed the body's profound capacity for adaptation, its resilience, its tireless will to mend and transform. We've seen it as a living scaffolding, a network of microscopic engines, a symphony of forces, a narrative of continuous silent work. But what happens when we step back, when we allow all these individual threads of understanding to weave themselves into a single, magnificent tapestry? What emerges when we cease to dissect and begin to perceive the whole, the gestalt of this miracle we inhabit. This is where the true wonder begins to unfold, where the deeper appreciation for the human body, not merely as a collection of ingenious parts, but as an utterly integrated, self-organizing, and profoundly wise entity, truly blossoms. We've seen the bones articulate, the muscles contract, the ATP ignite, the neurons fire, and the tissues adapt. Now, let's consider the grand orchestration, the ceaseless silent ballet that is you right now, in this very moment. Have you ever paused to consider the sheer mind-boggling complexity of simply being, the quiet marvel happening within you as you sit or stand or breathe? It's not just a collection of systems working in parallel. It's a confluence, a ceaseless dialogue, a living feedback loop where every single component is intimately aware of and responsive to every other. Imagine, if you will, a vast ancient city, but instead of buildings, it is composed of living cells, each a tiny bustling factory, and instead of streets, there are rivers of blood, carrying vital supplies and messages. The city has its power plants, our energy systems, its communication networks, our nervous system, its structural foundations, our bones and connective tissues, and its engines of action, our muscles. But unlike any city we could ever design, this one is utterly self-sustaining, self-repairing, and possessed of an innate intelligence that defies our most sophisticated algorithms. This is the deeper truth of biomechanics, the profound realization that emerges from our patient contemplation. The human body is not merely complex, it is integrated to a degree that borders on the divine. Every twitch of a muscle fiber sends ripples through the fascial network, informing the joint mechanics. Every joint angle sends proprioceptive signals back to the brain, fine-tuning the motor command. Every metabolic demand triggers a cascade of hormonal and respiratory adjustments. It is a feedback loop without end, an endless conversation between structure and function, between demand and supply, between intention and execution. Think of it. As you reach for a cup of tea, your motor cortex has already planned the trajectory, your basal ganglia has smoothed the motion, your cerebellum is coordinating the timing. But simultaneously, your eyes are feeding visual data, your skin is anticipating the texture and temperature, your muscles are adjusting their tension based on the perceived weight, your bones are providing stable leverage, and your heart and lungs are subtly adapting their rhythm to the minimal energy expenditure. All of this in milliseconds, without a single conscious thought. It's a symphony played by an orchestra of billions of cells, each a virtuoso, each perfectly attuned to the others. This seamless integration extends beyond the mechanics of movement into the very essence of our being. Our emotions, our thoughts, our memories, they are not separate from this biological machine. They are interwoven, expressed through the very same neural pathways and chemical messengers that govern our physical actions. The stress of a deadline can tighten our shoulders, altering our posture and breathing mechanics. The joy of a reunion can lighten our step, infusing our movements with a vibrant elasticity. The body listens, responds, and expresses, often in ways that precede our conscious awareness. It is a living, breathing testament to the unity of mind and matter. And this unification, this incredible integration, is never static. It is a dynamic equilibrium, constantly seeking balance, constantly adjusting, The very act of living, of interacting with the world, is an ongoing experiment in biomechanical adaptation. Every step you take on uneven ground, every time you lift something heavy, every moment you hold a posture against gravity, you're engaging this intricate network in a continuous dance of challenge and response. Your body is not just performing, it is learning and evolving in real time, its wisdom deepening with every lived experience. This inherent wisdom of the body, its capacity to self-organize and self-repair, is perhaps the most humbling aspect of our study. We've spoken of Wolff's law, of said principle, of neurological plasticity. These are not abstract scientific concepts. They are testaments to the body's profound, almost spiritual intelligence. It knows how to mend a broken bone, how to rebuild a torn muscle, how to reroute neural pathways after injury, how to strengthen itself in response to demand. It possesses an innate blueprint for health and resilience, a silent guardian always working towards equilibrium, towards survival, towards flourishing. This understanding, this deep appreciation for the integrated narrative of the human body, transforms our relationship with ourselves. No longer can we view our bodies as mere vehicles for our minds, or as machines that occasionally break down. Instead, we begin to perceive them as living partners, as wise companions on our journey through life. We learn to listen to their subtle cues, to honor their needs, to marvel at their enduring capacity. It changes how we move, how we exercise, how we rest, how we nourish ourselves. When we understand the elegant mechanics of a lever, we move with greater efficiency. When we appreciate the intricate dance of muscle contraction, we train with greater intention. When we recognize the body's capacity for adaptation, we approach challenges with patience and trust. We become better stewards of this incredible gift, not out of obligation, but out of a profound sense of wonder and gratitude. This is the ultimate invitation of biomechanics, to step beyond the textbook and into the living experience, to feel the silent symphony within, to observe the ceaseless work of integration. It is an invitation to inhabit your body with greater awareness, greater respect, and greater joy. To see every movement, from the simplest breath to the most complex athletic feat, as a testament to an intelligence far grander than our own. So, as we bring our formal explorations to a close within the tranquil halls of Dreamy Academy, remember that the true classroom is everywhere. It is in the effortless grace of a child at play, the steady gait of an elder, the focused intensity of an athlete, the quiet rhythm of your own breath. The language of human movement is spoken all around us, and indeed within us always. May this journey have opened your eyes not just to the mechanics, but to the magic. May it have ignited within you a lifelong curiosity, a gentle reverence for the universe within each of us. For the study of human movement is never truly finished. It is an endless source of wonder, a continuous unfolding of discovery, a testament to the astonishing, elegant, and integrated miracle that is life itself. Thank you for embarking on this slow and thoughtful adventure with us. The journey continues, always within you. And so, we arrive at a threshold, don't we? We've journeyed through the intricate landscapes of bone and muscle, tracing the invisible currents of energy, witnessing the silent commands of the nervous system, and marveling at the body's boundless capacity for adaptation and integration. We've collectively stood in awe of the human form, recognizing it not merely as a collection of discrete parts, like gears in a machine, but as an utterly integrated, self-organizing, and profoundly wise entity, a living, breathing miracle. We've seen the skeletal framework, an architectural masterpiece of resilience and grace, providing structure while allowing for fluid motion. We've explored the muscular tapestries, a vast network of fibers ready to spring into action, contract and release with astonishing precision. And beneath it all, the silent hum of metabolic energy, an unseen powerhouse fueling every single cell, every thought, every beat of the heart. The nervous system, a lightning-fast communication network, orchestrating billions of signals every second, ensures that every component works in perfect concert. But what does this grand understanding truly mean for us, for you, in the quiet cadence of your daily life? How does this deep dive into the biomechanics of being transform your perception of yourself, of the very vessel you inhabit? You might find yourself wondering. Quote 15. It's precisely in these mundane, often overlooked moments that this understanding finds its deepest meaning. This isn't just an academic exercise, a beautiful theory to be admired from a distance. It is, in its essence, an invitation to step beyond the lecture hall, beyond the diagrams and the scientific explanations, and into the rich, vibrant, ever-present reality of conscious embodiment. It's an invitation to not just have a body, but to truly as be in it, with a heightened sense of presence and connection. Have you ever paused to consider what it might mean to truly live within this integrated miracle, with an awakened awareness of its ceaseless dynamic feedback loops? To move not just through the world, pushing and pulling against it, but with an exquisite understanding of the universe within you, to feel the ground beneath your feet not as a mere surface, but as a source of feedback, a partner in your movement. This is where our journey culminates, not in a final answer, a definitive conclusion neatly tied with a bow, but in a profound shift in perspective, from observer to participant, from intellect to lived experience. It's about moving from merely knowing about your body to deeply knowing your body from the inside out. We've learned that every step you take, every breath you draw, every gesture you make is a symphony of forces, a meticulously choreographed dance of systems. Your bones articulate like ancient, perfectly oiled gears, gliding effortlessly, lubricated by synovial fluid that ensures smooth, frictionless motion. You can almost feel the resilient strength within them, providing support for every action. Your muscles contract with the precision of microscopic engines, bundles of fibers generating immense power or subtle adjustments, fueled by the tireless work of cellular powerhouses, mitochondria humming with life. Your nerves hum with electrochemical messages, a constant silent chatter, orchestrating every nuance, from the blink of an eye to the most complex athletic feat. And all of it, all this astonishing complexity, is happening right now, silently, effortlessly, beneath the surface of your skin, a hidden marvel unfolding moment by moment. But conscious embodiment asks us to bring this silent marvel into our awareness. It asks us to feel the subtle shift of weight as we rise from a chair, noticing the engagement of our glutes, the gentle pressure through our feet, the lengthening of our spine. It asks us to sense the gentle unfurling of the spine as we reach for a cup, feeling each vertebra articulate, the stretch in our ribs, the extension of our arm as a natural continuation of our core. It asks us to perceive the rhythmic engagement of core muscles as we walk, sensing the deep stability they provide with each stride, keeping us balanced and upright. It's about cultivating a deeper, more intimate relationship with our own physical presence, transforming mundane movements into moments of profound connection with the self, turning the ordinary into the extraordinary. Think for a moment of walking. Before our explorations, it might have been a simple unconscious act, a means to an end. Now, perhaps, you perceive it differently. You sense the slight, almost imperceptible tilt of the pelvis, guiding each leg forward. You feel the elegant swing of the arms counterbalancing the legs, a natural, energy-efficient rhythm. You become aware of the gentle push-off from the ball of the foot, propelling you forward, followed by the intelligent absorption of impact through the ankle, knee, and hip, cushioning each step. You feel the constant dynamic equilibrium maintained by your core, the intricate neural commands firing with split-second timing, the energy systems providing their precise fuel for sustained movement. When you bring this heightened awareness to the act, walking ceases to be merely locomotion. It becomes a moving meditation, a living testament to the body's extraordinary wisdom, a dialogue between you and the ground beneath you. Ah, you might think, this isn't just my legs moving. This is my entire being in motion, beautifully coordinated. This conscious awareness is not about overthinking or intellectualizing every movement, dissecting it into its constituent parts until the joy is lost. Rather, it's about fostering a profound listening. Our bodies are constantly communicating with us, sending signals through a language of sensation that is often overlooked in our busy, externally focused lives. These are the whispers of our integrated miracle, subtle cues of tension, fatigue, fluidity, ease, or discomfort. They are gentle nudges, quiet suggestions, echoes of our internal landscape. Imagine your body as a wise elder, a lifelong companion, always offering gentle guidance, always providing feedback without judgment. A slight stiffness in the shoulder might be a whisper about posture, a silent commentary on how you've been holding yourself, or perhaps accumulated stress from a demanding day. A persistent ache in the knee could be a quiet suggestion for altered movement patterns, a need for rest, or a gentle reminder to modify an exercise. Before, you might have dismissed it with a shrug or simply pushed through. Now you might pause and consider. Quote, 18. Too often, we ignore these whispers until they escalate into shouts, into debilitating pain, chronic injury, or profound discomfort that can no longer be ignored. Conscious embodiment encourages us to attune ourselves to this internal dialogue, to learn the nuances of our body's unique language, and to respond with care, respect, and proactive understanding. It's a fundamental shift from viewing the body as a machine to be driven, pushed to its limits, and only maintained when broken, to a living, breathing partner to be collaborated with, nurtured, and respected. And this collaboration extends beyond mere physical mechanics. We've touched upon the neural control of movement, the brain's role as master orchestrator, the central command center. But the connection runs deeper still. Our mental and emotional states are not separate from our physical being. They are interwoven threads in the intricate tapestry of our embodiment, each influencing the other in a continuous, dynamic dance. Have you ever noticed how stress tightens your shoulders, causing them to hunch defensively, or how anxiety constricts your breath, making your chest feel tight? Conversely, how joy brings a spring to your step, making your movements feel lighter and more expansive, or how a feeling of confidence straightens your posture. This is the profound two-way street of mind-body interplay in action, a constant conversation between thought, emotion, and physical sensation. Consider the athlete who visualizes a perfect jump or a flawless swing before execution. This mental rehearsal isn't just psychological preparation, it's a powerful neurological priming. It activates the same motor pathways in the brain as the physical movement itself, refining the neural commands, enhancing coordination, and improving performance even before a muscle is physically engaged. The athlete feels the movement in their mind's eye, strengthening the neural blueprint. Similarly, sustained emotional states can subtly, yet profoundly, reshape our posture, our gait, and even the very tension patterns held within our fascia and muscles. Prolonged sadness can lead to a slumped posture, while chronic anger might manifest as a rigid jaw or tight fists. To truly embody ourselves consciously is to recognize this intricate dance between thought, emotion, and physical expression, and to harness it for greater well-being, emotional resilience, and freedom of movement. It's about consciously choosing to loosen the grip of negative emotions and allow the body to express a more expansive, free form. This understanding also illuminates the art of graceful aging and sustained vitality. As we age, our bodies naturally undergo changes. Collagen production slows, bone density may decrease, and muscle mass can diminish. But conscious embodiment allows us to navigate these transformations with greater wisdom and adaptability. By listening to the body's changing needs, by understanding its inherent capacity for adaptation, Wolff's Law, which states that bone adapts to the loads it is placed under, neurological plasticity, the brain's ability to reorganize itself, and muscle remodeling, the body's continuous rebuilding of muscle tissue. We can tailor our movements, our activities, and our self-care practices to support longevity and maintain functionality. It's about moving with our body rather than against it, not pushing through pain or ignoring limitations, but modifying, adapting, and finding new ways to move joyfully and effectively. It's about fostering a lifelong partnership built on respect, intelligent engagement, and a deep appreciation for the body's evolving wisdom. The journey of biomechanics, as we've explored it here in Dreamy Academy, is not about finding a destination, a final answer that solves all riddles. It is about deepening an ongoing relationship, a lifelong exploration. It is about cultivating a quiet reverence for the astonishing complexity and elegance that resides within each of us. It is about transforming the abstract scientific understanding into the intimate, the deeply personal, and the profoundly felt. It's about realizing that the most intricate engineering isn't found in a laboratory, but within your very own skin. So, As we bring this particular series of explorations to a close, remember this: the most extraordinary laboratory, the most sophisticated piece of engineering, the most integrated miracle you will ever encounter is your own body. It is a constant source of wonder, a testament to billions of years of evolution, a silent, tireless companion on your journey through life, faithfully carrying you through every experience, every challenge, and every triumph. It is always there, always ready, always working for you. May this understanding inspire you to move with greater awareness, to listen with deeper intention to its subtle cues, and to live with a profound appreciation for the integrated miracle that you are. The lecture may end, but your personal journey of conscious embodiment, of discovering the endless wisdom within, has only just begun. Go forth and move beautifully. And so, here we are, at a new threshold, having journeyed through the intricate landscapes of bone and muscle, energy and nerve, adaptation and profound integration. We've learned to listen, to tune into the silent symphony playing within. Now, in this 9th chapter, we invite you to move beyond the contemplation of the body's wisdom to its active, conscious application. This is where theory blossoms into practice, where understanding transforms into the art of living movement. Have you ever considered that every single movement you make, from the most mundane to the most magnificent, is a unique, fleeting masterpiece? A complex negotiation between internal forces and external realities, a conversation with gravity and the ground beneath your feet. We embark now on a deeper exploration of what it means to craft this masterpiece, to become not just an observer, but an active architect of your own biomechanical expression. We've seen the body as a marvel of engineering, a living scaffolding, a network of microscopic engines. But to truly appreciate its genius, we must see it in motion, not just as a collection of parts, but as a dynamic, flowing system. Think of a dancer whose every limb seems to extend an invisible line of energy, or an athlete whose movements appear almost effortless, a testament to years of refined practice. What makes their motion so compelling, so efficient, so utterly fluid? It is the conscious, or often unconscious, mastery of biomechanics. We begin with the concept of efficiency and economy of motion. Our bodies, in their inherent wisdom, are constantly striving for the path of least resistance, the most energy-conserving route. This isn't laziness. It is a profound testament to millions of years of evolutionary optimization. Every step, every reach, every lift is an opportunity to either squander precious ATP or to harness the body's inherent leverage and power with elegant precision. Remember our discussions on energy systems, the phosphagen, glycolytic and oxidative pathways. When we move with economy, we are honoring these systems, allowing them to function optimally, conserving reserves for when they are truly needed. Consider the simple act of walking. It might seem rudimentary, but within each stride is a complex dance of weight, transfer, muscular contraction, and joint articulation. A slight forward lean, the subtle swing of the arms counterbalancing the legs, the rolling contact of the foot from heel to toe. Each element, when aligned, reduces the work required from individual muscles. When we walk efficiently, we become a pendulum, using gravity and momentum to our advantage, rather than constantly battling them. Picture the difference between a brisk, light-footed stroll and a heavy, lumbering shuffle. One feels almost effortless, the other a chore. The difference lies in the biomechanical intelligence applied, whether consciously or unconsciously. We are not merely putting one foot in front of the other. We are engaging a finely tuned system of levers and fulcrums, powered by muscles, guided by nerves, all working in concert to propel us forward with minimal energy expenditure. This principle extends to every aspect of our physical lives. Lifting an object from the floor, for instance. Do you bend at the waist, straining your lower back? Or do you engage your powerful glutes and leg muscles, maintaining a neutral spine, allowing the strongest parts of your body to bear the load? This isn't just about avoiding injury. It's about channeling force through the most robust structures, respecting the design of your own living scaffolding. When we align our joints and engage our muscles in their optimal planes of action, we are allowing the body to perform as it was designed, powerfully, safely, and with profound grace. This is the quiet genius of the human form, an engine not just powerful but magnificently efficient, a testament to billions of years of refinement. Beyond mere efficiency, there is the captivating realm of grace and fluidity. What makes movement beautiful? It is not simply the absence of wasted effort, but the seamless, almost melodic transition between positions, the feeling of an unbroken line of energy flowing through the body. This is where our understanding of joint articulation and muscle coordination truly comes alive. Remember our first chapter, where we spoke of the intricate design of synovial joints, the ball and socket hips, the hinge knees, the gliding facets of the spine. These are not isolated units. They are interconnected segments of what biomechanists call kinetic chains. Imagine a ripple spreading across a pond. A single stone creates an effect that propagates outwards, influencing every molecule of water in its path. Similarly, in the human body, movement initiated at one joint creates a cascade of effects up and down the kinetic chain. A twist of the ankle can influence the knee, hip, and even the spine. When we move with grace, we are allowing these kinetic chains to function harmoniously, transmitting force and motion smoothly from one segment to the next, much like an orchestra where every instrument plays its part in perfect synchronicity. There are no abrupt stops, no jarring transitions, only a continuous flowing dialogue between body and space. Think of the exquisite control of a gymnast on the balance beam, or the sweeping arc of a tennis player's serve. These are not just displays of strength, they are masterclasses in kinetic chain integration. Each joint moves in precise relation to the others, creating a powerful, elegant, and seemingly effortless trajectory. This fluidity is also a hallmark of healthy, adaptable movement, indicating a well-coordinated nervous system and muscles that can both contract powerfully and relax completely. It's the difference between a stiff, robotic movement and one that feels organic, alive, and responsive. To cultivate this fluidity is to allow your body to speak its most eloquent language, to express its inherent wisdom through motion. It's about letting the energy flow, uninterrupted, from your core to your extremities, creating movement that is both powerful and poetic. This deeper understanding also empowers us in adapting movement for longevity and resilience. Our bodies are not static machines. They are living, evolving entities designed for adaptation, as we explored with Wolff's Law and the said principle. But adaptation requires thoughtful engagement. To move consciously is to move with an eye towards sustaining our physical capabilities throughout life, preventing injury and facilitating recovery. Consider the stresses we place on our bodies daily. Repetitive motions, prolonged static postures, or sudden unaccustomed loads can lead to wear and tear. Our biomechanical knowledge becomes a powerful tool for self-preservation. By understanding the optimal alignment of our joints, the proper engagement of our core muscles, and the intelligent distribution of load, we can mitigate these stresses. For example, knowing the vulnerabilities of certain joints, we can choose movement patterns that protect them, strengthening supporting musculature and avoiding extreme ranges of motion that might cause undue strain. It's about being a wise steward of your own physical vessel. Moreover, the body thrives on variety. While specific adaptations are crucial for skill development, a diverse movement diet ensures that all tissues are challenged in different ways, maintaining their resilience and adaptability. If we only ever move in one plane, or perform the same actions repeatedly, we risk creating imbalances and overuse injuries. Incorporating varied movements, reaching, twisting, bending, balancing, jumping, keeps our entire system robust, ensuring that the intricate network of fascia, tendons, and ligaments remains supple and strong, and that our neural pathways stay agile and responsive. This conscious diversification of movement is like cross-training for life, preparing our bodies for the unexpected and maintaining their youthful vigor. It's about listening to the body's signals of fatigue or discomfort, not as a sign to stop moving entirely, but as an invitation to adjust, to modify, to explore different pathways of motion that support rather than deplete. Finally, we arrive at the profound realization that movement is a personal narrative. Just as each of us has a unique voice, a unique fingerprint, we each possess a unique movement signature. Your gait, your posture, the way you gesture. These are all expressions of your personal history, your experiences, your emotions, and your intentions. Your body holds the silent story of every fall, every triumph, every moment of stillness, and every burst of energy. This understanding invites us to experiment, to explore, and to discover the vast range of possibilities within our own bodies. There is no single perfect way to move, but rather an infinite spectrum of optimal ways, tailored to your individual structure, your current state, and your specific goals. What feels graceful to one person might feel awkward to another. What is efficient for a long-distance runner differs from what is efficient for a weightlifter. This is where the journey of conscious embodiment truly becomes a journey of self-discovery. We encourage you to observe your own movements with curiosity and compassion. Where do you hold tension? Where does your body feel restricted? Where do you find effortless power? These observations are not judgments, but invaluable data points in your ongoing dialogue with your physical self. By consciously engaging with your biomechanics, you're not just optimizing your physical performance, you're deepening your relationship with your body, transforming mundane actions into moments of profound self-awareness and self-expression. Every movement becomes an opportunity to write a new chapter in your personal narrative, to express your unique vitality and spirit. In Dreamy Academy, we believe that understanding the science of human movement is not merely an academic pursuit. It is an invitation to live more fully, more vibrantly, and more harmoniously within your own skin. To move with conscious awareness is to reclaim a fundamental aspect of your humanity, to reconnect with the innate wisdom that resides within every cell of your being. It is to find joy in the simple act of putting one foot in front of the other, to marvel at the strength in your muscles, and to appreciate the profound elegance of your design. The journey of discovery is never truly over. It continues with every breath, every step, every conscious engagement with the world through your magnificent body. We have laid the foundations, unveiled the hidden mechanisms, and invited you into a deeper relationship with your physical self. Now, the canvas is yours. Go forth, move with intention, dance with gravity, and craft your own biomechanical masterpiece, one conscious movement at a time. The world awaits the unique narrative of your motion. Welcome back, dear explorers of the human form, to our shared space within Dreamy Academy. We've journeyed through the intricate blueprints of our living architecture, marveled at the microscopic engines that power our every gesture, and witnessed the symphony of systems that orchestrate our existence. We've understood the profound wisdom embedded within our very cells, the ceaseless adaptation, the quiet resilience. And in our last contemplation, we began to embrace the concept of conscious embodiment, that profound partnership with our extraordinary physical selves, cultivating efficiency, grace, and fluidity in our movements, recognizing each motion as a personal narrative. Now, as we gather once more, let us move beyond understanding how our bodies work, to exploring the art of making them work with exquisite precision, with profound intention. We embark on the path of becoming conscious sculptors of our own movement, refining the masterpiece that is the human form. For it is one thing to comprehend the mechanics of a lever, a muscle contraction, or a neural pathway. It is another entirely to integrate this knowledge into the subtle, powerful act of moving better, of living more fully within our own skin. Think of it. We are not merely passive recipients of our biomechanical destiny. No, we are active participants, endowed with the capacity to shape, to refine, to elevate our physical expression. We are the conductor of our body's orchestra, and with each passing moment, each conscious breath, each deliberate step, we have the opportunity to fine-tune its performance. This is where the science of biomechanics truly blossoms into an art form, the art of embodied motion. Have you ever watched a dancer glide across a stage, a martial artist execute a swift, precise strike, or an elder move with an almost ethereal ease, despite the years? What you observe is not just strength or flexibility, but a profound understanding, often intuitive, of movement, economy, and grace. This is the goal we now contemplate, to strip away the superfluous, to amplify the essential, and to move with a quiet power that resonates from within. Our journey begins with the brain, that magnificent orchestrator we've previously admired. We spoke of motor learning, of the cerebellum's role in coordination and skill acquisition. Now, let us consider how we actively engage these neural pathways to rewire our movement patterns. Every time we attempt a new skill, perhaps a more balanced walk, a more ergonomic lift, a more graceful reach, we are literally forging new connections, strengthening existing ones, and pruning away the inefficient. It's like carving a new riverbed for a stream. Initially, the water might meander, but with persistent flow, a clear, efficient channel emerges. This process demands a unique blend of focused intention and patient contemplation. We are asking our nervous system to learn a new language, to write a new script for familiar actions. This isn't always about brute force repetition. It's about repetition with awareness. It's about listening intently to the body's feedback, those subtle whispers from our proprioceptors, the gentle nudges from our joint receptors. When we lift an object, are we bracing correctly? Is the spine neutral? Are the legs engaged? These are not trivial questions. They are the vocabulary of efficient movement. Consider the concept of efficiency in motion. It's not just about speed or power, but about achieving the desired outcome with the least amount of wasted energy, the most harmonious recruitment of muscles, the most intelligent engagement of levers. Imagine a finely tuned engine. Every part works in concert. No energy is lost to unnecessary friction or misaligned components. Our bodies too strive for this elegant economy. When we move inefficiently, we place undue stress on joints, overwork certain muscles, and invite fatigue or even injury. Our goal is to cultivate movement that feels effortless, even when it demands great strength. This pursuit of efficiency often involves unlearning as much as learning. Over years, we develop compensatory patterns, often unconsciously, in response to injury, habitual postures, or societal norms. Perhaps we favour one side, slouch when seated, or carry tension in our shoulders. These patterns become ingrained, etched into our neural pathways like deep grooves. To optimize our movement, we sometimes need to gently, patiently, guide our bodies out of these old habits, to soften the deep grooves and carve new, healthier ones. It's a delicate dance of releasing old tensions and embracing new possibilities. This is where the direct, intimate dialogue with your own body becomes paramount. We've discussed the constant stream of sensory feedback, the body's internal navigation system. Now we learn to truly interpret that data. When you walk, do you feel the gentle roll from heel to toe, the engagement of your core, the swing of your arms? When you reach, do you sense the articulation of your shoulder, the extension of your arm, the grasp of your hand? This heightened proprioceptive awareness transforms movement from an unconscious act into a conscious, mindful practice. It allows you to become your own best coach, identifying areas of stiffness, imbalance, or unnecessary effort. Think of your body as a living, breathing instrument. Just as a musician tunes their instrument before a performance, we too can tune our bodies through conscious practice. Stretching, strengthening, balancing, coordinating. These are not just exercises. They are acts of tuning. They prepare the instrument, refine its sound, and expand its expressive range. And the beauty is, this instrument is always with you, always ready for refinement, always capable of new melodies. The impact of this conscious refinement extends far beyond athletic prowess. It permeates every aspect of daily life. How you sit at your desk, how you lift your child, how you garden, how you carry groceries. Each of these actions can be transformed from a potential source of strain into an opportunity for graceful, efficient motion. Imagine navigating your day with less fatigue, fewer aches, and a greater sense of ease. This is the promise of embodied motion. Furthermore, This journey of movement optimization is deeply personal, a unique reflection of your individual history, your goals, your aspirations. Your movement narrative is unlike anyone else's. It is a story told through the subtle shifts of your weight, the arc of your limbs, the rhythm of your gait. It speaks of your resilience, your joy, your challenges, your victories. To refine your movement is to refine your narrative, to write a chapter of greater strength, deeper grace, and profound harmony. And it is a lifelong endeavor, not a destination. The body is in constant flux, adapting to age, environment, experience. Therefore, our relationship with movement must also be dynamic, evolving, and continuously curious. There is always more to discover, more to refine, more to appreciate. This is not a burden, but an invitation to a perpetual dance of self-discovery, a continuous conversation with the miracle that is your own physical form. So as we draw this chapter to a close, let us carry forth this understanding that biomechanics is not just a study of physics applied to biology. It is a profound philosophy of living. It empowers us to move not just instinctively, but intelligently. Not just mechanically, but artfully. It calls upon us to listen to the body's wisdom, to honor its design, and to actively participate in shaping our physical experience. Let us embrace this ongoing adventure of embodied motion, cultivating not just strength or flexibility, but a profound sense of integration, a seamless flow between mind and body. For in this mindful movement, we find not only efficiency and grace, but a deeper connection to ourselves, to the world around us, and to the boundless wonder of life itself. We are not just movers, we are artists, perpetually sculpting the living masterpiece that is our own extraordinary human form.